Welcome, everyone. Dear author and invited guests, welcome to a technical session 3D. On the behalf of Team WS4 2021 and the Global Knowledge Research Foundation, it's my great pleasure to welcome you to the 5th International World Conference on Smart Trends in System Security and Sustainability through Zoom. We are thankful to everyone who present on this platform. Go along with us digitally for this conference in this unpredictable circumstances of COVID-19. Also, we wish everyone for their and families for the protected time, and we all will pass this soon together. We hope you will enjoy 2 days of interactive sessions and knowledgeful session. Just before we get started, I would like to introduce our session chair, Dr. S.M. Hassan, has received a PhD degree in computer science and technology from the University of Electronics Science and Technology of China. He is working as an assistant professor with the Department of Computer Science, American International University, Bangladesh. He has published many research articles in a reputed conference and journals. His research interest includes machine learning, deep learning, biometrics, discovery, and a pattern recognition. Welcome to you, sir. Now we can start our presentations. I would like to invite our first presenter, Ajay. He's presenting a paper on a detection of Alzheimer and a disease through speech feature and a machine learning classifier. Dear presenter, you may start your presentation.
Yeah, thank you. Thank you very much for the opportunity. I hope I am audible to you.
Yes, Ajay, you are audible. Please start your presentation.
Thank you. Thank you. I will be sharing my presentation. Yeah, thank you. Yeah, I hope it was the full screen display. It was there. Yeah. Can you please confirm it so that I can move further?
Yes, it is.
Yeah, thank you. Thank you very much for the acknowledgement. Thank you, everyone, for giving an opportunity to present my research activity in this conference. First of all, I want to say that this particular presentation is regarding a review based on the detection of Alzheimer's disease through speech features and machine learning classifiers. So in this, the review, I would mention that what sort of disease it is and what were the various types of speech features that are made available so that we can able to detect the disease with higher accuracy. And also along with the speech features, what sort of machine learning technologies classifiers would help in the detection of the disease. Yes. Let me proceed. So here on the screen, you're having the contents of the presentation. At first, I am going for the introductory part, and then I will be giving the generalized disease detection flow. And later on, I will be explaining the different types of databases that are available. That means such kind of repositories which are available for the research activity, and certain signal processing methods that are useful in the signal. That means these signal processing methods are very much useful for the extraction of the features from the audio signals, and also the different types of features that were used in this classification, and what were the different types of classifier algorithms that were utilized. So these are the things that were being covered in the presentation. So let me introduce with this concept. The first thing is the most common disease is in the elderly people is like Alzheimer's disease, and it's a kind of dementia. in which we can observe the brain will be shrinking and also the nerve fibers get reduced. So with this one, there might be certain mental, cognitive, and also linguistic features were disturbed in the patient. So it is more common in the elderly people, and also whenever the severity is high, it may lead to the death of the elderly people. So for this one, the spontaneous speech or also the extracted features were available so that we could able to detect some the progression of the disease, and also what sort of disease it is. Is it an Alzheimer's disease or Huntington's disease, or is it an autism kind of dementia? So these kind of things we can detect based on the spontaneous speech. Okay, and whenever it is an early kind of detection, then we may could able to go for development of new treatments, and also we could able to monitor the progression of the disease, and so that we can go for more care for the elderly people. Okay, at present we are having the other types of technologies rather than the spontaneous speech. We have the electroencephalographic and also MRI based analysis, which might be a little bit costlier. So the speech based signal, that means the speech based detection might be a little bit more, that means little bit lower cost, and also it is easily available, and accuracy is also observed at a higher rate. Okay, let me show it to you. So here on the screen, we are having the generalized disease detection flow, in which the disease detection flow starts with the speech data acquisition. That means different kinds of speech-based data might be recorded here by using some acoustic audioid and also smartphones. So at first, the recordings will be done, and while it was recording, the patient will be given with certain topics, it might be a topic on certain picture perception, or it might be some recalling based explanation, or some kind of general descriptions or general kind of conversations between the elderly people and also different age groups. And in this, while we are recording the data, that means while we are recording the speech, the demographic kind of details will be like, it can be from male or female, or it can be from any kind of age groups, so that it might be a mix up of data we can have. And when it is the pre-processing stage, we actually standardize the signal so that we can extract the features properly. Okay, in which we first identify the voice data, and also we identify the unvoiced data, and based on this voiced and unvoiced data, we can standardize the signal, and also we can apply some randomization and some normalization, removal of the outliers. These kind of things might be done in the pre-processing stage. And after processing the audio signal, then various types of signal processing methods were applied to extract the crucial features which might be useful to identify the impairment in the speech. And these impairments can be marked clearly based on these extracted features. And then these features might be forming like a vector, and along with these feature vectors, it is very much essential to go for the training the data based on a classifier. So here the selection of classifier is very important. Why? Because in order to identify an individual, whether he is in healthy control or is he an Alzheimer's disease patient. Okay, so the classifier selection makes a very much key role here. Okay, let us see here how the discrimination might be done. We can observe. So there are several kinds of databases that were already available as a repositories, and certain health communities, and also several clinical trials were done based on it. And the voice signal of the patient and also the healthy control people were recorded for the experimental evaluations. And these speech data may be a collection of the different age groups, and also the people with Alzheimer's disease, the people with mild cognitive impairment, and also the healthy controls. And the prominent kind of repositories that are available are like a DEM at the rate care project, BEA Hungarian spoken language database, and Pentry Bank switchboard corpus, and dementia bank. These are the prominent kind of repositories that are available for the experimental evaluations. Okay, in addition to them, several customized data sets were also there. And these data sets may be recorded in various regional accents and also languages. So at first, we need to apply certain algorithms in order to identify the regional accents and also languages, so that the detection can be a little bit more accurate. Repository based and also the customized speech data sets are summarized in the table one. Okay, here on the screen we are having the table one. So here there was a summarization for the databases. Okay, as said earlier, there are prominent databases like which was recorded by the institution that is the patients, and Alzheimer patients are around 26 were taken in this data set. And in this one, see, there are different types of voice tasks. Okay, certain voice tasks may be like counting backward. That means they may be given with the numbers and they have to count it back, or it might be a sentence repetition task, or some kind of image description task, or sometimes it might be verbal fluency tested. Okay, these are the different types of databases we can observe. Like a Hungarian database is also there, which was recorded at Hungary with 75 number of speakers, and around 225 recordings were taken. So in this one, the voice talks taken like they need to talk at least 1 minute on an animated film, or it might be on the second day they have to recall back some kind of data. That means whatever the animation film they have seen on the first day, they have to repeat it on the second day. And whatever the video or whatever the film they have seen on the second day, they have to recall it back on the third day. Likewise, based on the recalling rate and also based on their fluency and whatever the cognitive skills they have, all these things can be identified based on these kind of tasks. Okay, so there are certain customized data sets also, like data set one, we have named it as data set one, data set two, data set three. These are certain customized kind of data set. Okay, in which various types of clinical organizations has involved in it, and like a Alzheimer's Foundation or a Broca Hospital in Paris, like CREA, University of Salamanca. Okay, these are the different types of organizations involved in these clinical recordings. Okay, in which the data
Sorry
sets
to
were
interrupt you,
very like,
sir, but
yeah, yeah,
you have
yeah,
last 2 minutes.
yes, okay, I will be moving forward.
Thank you.
So these are the different types of data sets we have on this. I hope it was displayed to you. So in this one, the signal processing methods like non-parametric man-BT, you test one-way ANOVA spectrogram functions, MFCC, that is null frequency substral coefficient, or voice activity detection. These are the different kinds of signal processing methods or tools that were used to extract the features. Okay, each kind of tool or method may be used for extracting a specific kind of features. And so here we are having the feature sets like different types of feature sets like vocal features, acoustic features, demographic features, time based, that is time domain based features, prosodic, temporal, and emotional response and emotional temperature, autoregressive based features. So these are the different types of features that were extracted from the speech of the different kinds of individuals. And here we have the summarization, like the comparative kind of summarization we can see here. Different types of feature sets we have: vocal features, acoustic features, linguistic feature, acoustic and linguistic combination, demographic, linguistic and acoustic features combination. So based on these types of features, you can observe the accuracies. The accuracy in detecting or accuracy in discriminating the person is like 79%, 87%, so on. So here we can observe the highest accuracies when we are using the ARP or some kind of emotional temperature based features by using different kinds of data sets. So these are the highest accuracies that is achieved in discriminating the person. And also along with the features, we definitely require a classifier in order to do some classification or discrimination. So here, certain kinds of classifiers that were observed, like SVM and two neural network, greedy approach, Bayesian networks. These are the different types of classifiers that are available. And it was observed that the classifiers like a Navi base or some decision tree, and also the k nearest neighbor, these are the different types of classifiers that has got the highest accuracy in disease discriminations. These discriminations can definitely vary based on the data set we have selected, and also the combination of the feature sets that were considered. So the here, while coming to the conclusion, we can conclude like different kinds of individual blocks were explained in this general detection flow, and also various features like vocal, acoustic, linguistic, demographic, time-based, prosodic, temporal. These kind of features has shown different kinds of accuracies in the discrimination, and the several classifiers has shown that it was greater than 90% of accuracy in discriminating the diseases, and especially while focusing on k nearest neighbor with the ARB based features, it was around 97% of accuracy observed, and above 95% of accuracy is observed for multi-layer perceptron and deep learning based convolutional neural networks and generalized regressional neural networks. These are the things, these are the classifiers has got the accuracy of 90%, 95% and above accuracies in discriminating the disease between Alzheimer's disease and also mild cognitive impairment and the healthy controls. So here I'm going to conclude. This is a kind of review that was made based on several others contributions. Okay, around 50 number of references were taken here in this comparison. So here I'm going to conclude. Thank you. So if any kind of queries you're having, you can definitely throw it out. Thank you. Thank you for the opportunity.
Hello, Ajay.
Yes. Yeah, I'm Ajay. Yes.
Myself, Jobin France. I'm listening your presentation. Your presentation was nice.
Yeah,
My question is,
yes.
how did you overcome the issue of like overfitting during your training?
While we are doing the training process, especially overfitting means at the time of let's go for the general flow.
Like the overfitting in the sense, like if the data
Then
is
we
being
could
trained.
have a more clarity.
Hello.
Yes.
If the data is being trained more, like the issue of overfitting may come. I mean, it may arises. So
yes,
it may
definitely,
affect the classification accuracy as well, right? So that's why I was just asking.
Definitely. So this was especially while we are doing the pre-processing stage, we could able to eliminate certain kind of unwanted and also which may cause certain kind of that means dragging down the accuracy kind of things. So at the time of pre-processing itself, we can standardize the signal, and also the features, whatever the thing that were extracted, that was observed. See here in this presentation, only few types of features were presented which has performed well in the even which could able to overcome this kind of overfitting, and then I have presented it. And even when we are coming for the experimentation, this is a combination of feature set and also the classifiers that were chosen. So even the overfitting can be identified here, so which may be reducing the accuracies.
Okay.
Yes.
What are the evaluation measures that you have taken, like in order to test the ability or the efficiency, in order to check the efficiency of the algorithm? What are the evaluation measures?
Just want to mention one thing here. I haven't done any experimental kind of procedure. This is based on the review. That means I have given a review or a summarization based on various others accuracy results, and also I have referred several others contribution, and then I have presented it. So I haven't gone through the experimental implementation.
So you did not perform any experiments, but you have just reviewed some of the most recent journals about the classification of these things, right?
Yes, exactly. Yes.
Thank you.
Yeah, thank you very much.
Thank you so much, presenter, for a nice presentation. I kindly request to remind you one thing: only session chair will ask a question. Nobody, any presenter, if you have any question, you may write down on chat box.
Yeah. Yes.
So, dear session chair, if you have any questions, please ask.
No, please ask to next presenter. I have no question
Okay.
right now.
Done, sir.
Thank
So
you.
I would
Thank you
like,
very much. Yeah.
now moving ahead, I would like to invite our next presenter, R. Jyotsana. She's presenting her paper on smart farm water requirement analysis using machine learning.
Hello.
Hello. Yes, Jyotsna, please, you may start your presentation.
Yeah, sure. Is my screen visible?
Yes, please go ahead.
Greetings. Hope everyone are doing fine amidst the pandemic. I'm Jyotsna, virtually present here to give a demonstration on our project named Smart Farm Water Requirement Analysis using machine learning. My teammates include Akshay, Malvin, and Manoj. I'd like to appreciate your patience and attention for the next few minutes. India is an agricultural country, and around 70% of the people directly or indirectly depend on agriculture for their living. We know that a huge amount of water is used in the agriculture sector, which may cause overusage of water. So, effective measures have to be devised in order to efficiently use water without affecting the yield from agriculture. The model described in our paper proposes a design of generic IoT framework for improving water usability by effectively irrigating and fertilizing based on the crop's current requirements, environmental condition, and weather forecast. Smart farming plays an essential part in smart cities and is a necessary aspect. Furthermore, the need to reduce water waste has triggered new research directions in the quest for water saving solutions. More robotics and artificial intelligence are expected to debut into farming as a result of increased technology, such as the Internet of Things and machine learning. Thus, as a result, our project has two objectives: to forecast the weather, soil moisture, and temperature based on the available data, as well as to water the plants appropriately. In recent years, technological advancements such as the use of computer systems and data transfer have brought about significant improvements in the farming working environment. Smart farming, which is focused on the integration of information and communication technology into agricultural machinery, machines, and sensors, allow for the generation of a large amount of data and statistics with the gradual introduction of automation into process. In countries such as US and Japan, wide-scale use of smartphones and Internet of Things systems have led to increase in of the growth in precision agriculture solutions. Smart farming and smart agriculture literature is relatively new. The phenomenon of smart farming is being propelled by remarkable process in the Internet of Things and machine learning. Meteorological patterns such as the temperature, wind speed, sun, humidity, and precipitation are the foundation for progress in this field, also including the convergence of internet technology and future-oriented technologies for use as smart objects. Agriculture being a vast domain to work on, our team opted the problem statement to deal with the scarcity of water. Due to increase in water pollution as well as variety of other variables that adversely influence water availability, and about farmers working in harsh climate, be it stormy rainy days or scorching sunny days. After choosing the problem statement, our team spent few days analyzing it and arrived to propose a technique which introduces to smart farming, a practical, cheap, and easy to develop task that are used to increase the productivity of agricultural products. The combination of smart irrigation and control to machine learning algorithms can stave off many issues of agriculture. In this machine learning project, we have used two main things, namely dataset and algorithms that allows one to quickly determine the water requirements of a certain crop during a specific season, which also provides recommendations so that the user may know which crops to plant in order to maximize production. This initiative is primarily focused on assisting farmers in managing crop water requirements in order to increase production and profitability. We make predictions using machine learning regression analysis, a compilation of mathematical tools for estimating relationships between dependent variable and one or more independent variable is known as regression analysis. A dataset is taken from a web source. The period covered by the meteorological data is from February 2021 to May 2021, consisting of humidity, temperature, wind speed, solar irradiance, etc. This data is fed into machine learning algorithm to get the prediction of water needed for a crop. The model is selected according to the data fitting. One of the models we are using is multiple regression model. With temperature, soil moisture, wind speed, sunlight, and humidity being the parameters of the meteorological data, ETC being dependent on them is taken into consideration for the model briefed in this paper. The data set should be pre-processed data by making the data clean for better accuracy. We find the correlation with the features by pair plot or heat map. The data set is divided into training set and test set, 70-30 or 80-20 ratio. We have to remove the missing data and outliner of data points. By doing data mining, we find insights and useful information. We do this by finding a correlation between target and features with the help of data visualization. With data analytics, we can do feature extraction and derive useful information by common. We have KC as a key feature, which has an initial stage, mid stage, and final stage for the growing crops. With respective crop coefficient KC, we optimize the data set by splitting it equally into train set and test set, which has an equal split of all the three stages in both steps. By doing this, our machine learning model will understand the underlying logic. Finally, we split the data set into 80-20, that is train set and test set. Now our pre-processed data set is ready to go into the model. The main formula used here is ETO star KC equals ETC, where ETC is the amount of water required by the crop, KC is the crop factor, and ETO is the evapotranspiration rate. In addition, here we show model selection performance measures. Firstly, we give our pre-processed data as the input for training models. We have taken 3 supervised models like linear regression, decision tree, and random forest. After our model gets trained with the data, now it's ready for performance evaluation measure. We choose RMSE for our evaluation. The lesser the RMSE, the better the accuracy. We use basic conditional statements for finding which model gives the smaller RMSE score. With this, we selected linear regression model based on the RMSE score. Now we give the test set as input for our trained model. The prediction takes place and the predicted labels are displayed. The accuracy attained using the application's linear regression model is 94%. The picture in the slide depicts the 3 distinct outcomes of 3 separate models, which is an array of comparisons starting on the left-hand side with the predicted values and on the right-hand side with the actual value. The first array displays the comparison of a linear model, while the second displays the comparison of a decision tree model, and the third shows us the random forest model. Since visual data has greater influence on humans than written data, figure 2 here graphically represents the same comparison with different labels. And figure 3 shows the numerical value of accuracy obtained with linear regression being the highest as 94%. The applications of the proposed model include affordability, making it easy to install across many agricultural fields and allowing farmers to rest on both sunny and stormy days. The method guarantees that the crop gets watered by concentrating on the previously mentioned climatological parameters. This device can water plants without requiring human intervention. Precision and machine learning are used in this low-cost, high-impact initiative to guarantee that the plants are watered according to their demands, while also taking care of the crop based on the meteorological variables, such as temperature, humidity, wind speed, and soil data. The advantages include it being affordable in addition to being easy to install, while the disadvantages include that this study proposes a machine learning technique for smart agriculture or farming that is only for maize. The model must be modified for different crops based on their KC, ETC, and ETO value. Hence concluding, the suggested idea provides a low cost, low power, and highly accurate method for predicting the amount of water necessary for maize. as well as reducing the human workload of watering plants under harsh climates such as summers or bitter winters. Smart farming would be more effective when we know the expense and the market value of water and plants. This would also be economical as the weather issued based on the minimal and effective amount predicted by the model. The project's future potential is enormous and can be scaled up in the future. As it is extremely adaptable in terms of growth, the project may be upgraded in the near future as and when the need arises. Given the fast growth of the population and the emergence of several new technologies throughout the years, it is critical that the agriculture sector shall soon follow. This idea might be better developed and it could be linked to a mobile application so that farmers may complete their work even while they are not at home. Drones may also be used to collect real time data and monitor the progress of the crops. It will be exciting to witness innovation in the agriculture sector. Thank you for giving this opportunity. Hello.
Okay, thank you. So I have a questions to you. Your research paper is related to smart farming,
Yes, sir.
water requirements analysis using machine learning. So my first question is, which algorithm you used as a classifier with your model?
So we actually use three algorithms, sir, as said. Like here, the linear regression, decision tree, and random forest. We finally chose linear regression because the RMSE was less and the efficiency was much better compared to decision tree and random forest. So we went along with the linear regression model.
Okay, my second question is, where from you get this data actually?
So we actually thought of collecting a real-time data from the NBS's research center, but because of the pandemic, we didn't get a proper opportunity to go there and collect it, and hence we thought of getting a data from the websites like Kaggle. So we got this data
Hmm.
that we used in a model from Kaggle.
So have you heard about deep learning model?
So as we started like learning machine learning, we thought of going along with the project, learn along with the project. So no, we are not it.
Okay,
Uh,
familiar with deep learning. Okay, it's okay. Okay, thank you.
yes, sir. Thank you so much for having us.
Now we can call our next presenter.
Yes, sure.
Rahul Anil Kumar. It's a paper present is a paper on automation on translating unit level verification scenario for test vector generation of SOC.
Hi, good evening, everyone. I'll just share my screen. I hope it's visible.
Yes, it's visible. Please go ahead.
Okay. So good evening, everyone, participants, session chair. I hope everyone is doing good in the time of this pandemic. My name is Rahul Anil Kumar, and I'm with the Indian Space Research Organization, Bangalore, India. And I, along with my co-authors, Mr. Varaprasad and Mrs. Padmapriya, would like to present this research work, Automation of Translating Unit Level Verification Scenarios for Test Vector Generation of SOCs. So this is a topic that will deal with the VLSI domain, and this is what we'll be going through today. I'll first take you through why system on chips have become an important part of the VLSI industry today, how verification of SOCs is done in the current context, and what we have identified as a verification gap here, how we propose to solve that verification gap, and how good our method is, discussing its strengths and weaknesses. So system on chips have been very popular, are becoming very popular in today's industry because you need a lot of functionality to cater to the increasing computing demands. So a system on chip is essentially a processor combined with multiple analog and digital blocks, and everything works together on the chip. So as you can expect, there is a huge cost and time involved in manufacturing an SoC. So it is critical to ensure first-time success. Now, verification of SOCs is a humongous task because there are a lot of blocks operating at the same time, and there are a lot of complex functionalities involved. So generally, the industry follows a divide and conquer approach. So verification is tackled at multiple hierarchies. The individual blocks are verified thoroughly first. We call it standalone verification. And then finally, they are integrated into the top level SOC and verified. So standalone verification is where most of the functionality is tested. Thorough verification happens there with the use of methodologies like UVM and features of system Verilog like constrained random verification. And once it comes to top level, we just test the basic connectivity and a few basic level test cases to see how the blocks are interacting with each other. Now, once we have fabricated the actual device in silicon, we need to test it for faults and some basic functionality. So for this, we use patterns generated by an automated test pattern generator tool. This will identify defects on the chip. And we use functional test vectors, which is a conversion of a top level test case used to test the device. Now, the motivation behind this study is that as we move ahead in technology nodes, there is a higher probability of defects occurring when you manufacture the device. And to test the functionality, you need functional test vectors. But the number of functional test vectors is limited by the number of top-level verification test cases available. So this is what we identified as a deficit. We have limited defect testing with ATPG, and the functional testing is very limited. Like you just test the basic functionality once your device is fabricated. So that way, our confidence on the device is less. You know that it basically functions, but are all the features working? So this can actually be addressed by generating more functional test vectors. But what are the challenges here? The one thing is generating a new functional test vector requires you to write a new top-level test case. This is a time-consuming task. And it is not possible to convert the standalone test cases, which already verify the functionality thoroughly, to test vectors directly. Now I'll tell you why this is so. Standalone verification is done as below. You have your standalone IP block, and I've partitioned the test bench into a stimulus and a checker. So this is where the thorough verification happens using methodologies like UVM. And the stimulus is usually provided by a UVM agent written in system Verilog. It can provide all kinds of random stimulus to the standalone IP block such that its functionality is thoroughly tested. When it comes to top level verification, the difference is this. Our standalone IP block sits here, but now it is being driven by the processor. And the stimulus for the processor is actually an application software that sits in the memory. Now this software has to go through the processor has to decode the instruction and finally drive the IP block. So the difference here is, here we have a thorough verification setup using system Verilog, but here the stimulus itself is in a different language. We can have a C language test case here. And the number of test cases that we write are limited to basic functionality checks and connectivity checks. So this is what we have identified as a verification gap. Because during standalone testing, we are testing all the functionalities, but we are not able to use it once we fabricate the device and want to test the device. So the solution we propose to this is to devise a technique to utilize the standalone scenarios to generate functional test vectors for device testing. Now, an automated method like this has two advantages. The first is that it reduces the burden on the verification engineers because he or she need not manually add more test cases. And second is it improves the confidence on the device because you have already tested the fabricated device for a detailed functionality. And this is how we go about doing it. So there are two steps involved. The first step is to convert the standalone test case into a software test case so that it can be run on the processor and you can get a top level test case. The second thing is to convert this top level software test case to test the device. So convert it into functional test vectors. So we follow a three-step process here, which will be outlined below. The first step is to extract the required information from the standalone test case. And the second is to generate the software test case for the top level verification, and finally to convert it to test vectors. So we demonstrated this technique on an I2C master protocol controller IP. I2C is a two-wire communication protocol. So the I2C master is actually a part of our SoC, which is driven by the processor. So this is a snapshot of the standalone environment. So the I2C is the only design under test here, and it is driven by an APB agent. APB is ARM's on-chip protocol. It's called Advanced Peripheral Bus. It is a protocol that the processor uses to communicate with the I2C. So our eventual goal is to replace the stimulus that is provided by this APB agent through a software test case. So the first step is to capture the information from the standalone test. So as we write the system Verilog stimulus sequence, we actually modify the test case to capture the data and control information that goes into the design under test. So if you see here, for each of the accesses happening on the APB bus, I have written out a sequence that will collect the data and the control information that has gone into it. So this way we collect it all in the log file. The second step is to convert the collected data into a software test case. So for this, we use an automated tool, and this automated tool will have the knowledge of the address space of the system on chip so that it can address each register separately. So this is how the conversion happens. If you see here, I'm doing a register write operation here, and the address and data is coming directly from the command that goes into the DUT. Now System Verilog has a feature where you can generate random stimulus. So all the random stimulus that it generates here is actually captured by this log file. So you get the exact equivalent software test case here. So here we are using a pointer-based access. So if you see this A00 is actually I2C control register. So the same thing that was written here also. And the data that comes here was actually collected from the log file here. So this way we have a direct equivalent of the standalone test case as a software test case. Now, step 3 is to convert this top level test case into a functional test vector. So for this, we simulate the top level test case and dump the simulation dump. It's called an EBCD file. And that file is taken to an in-house tool, which will convert it into a bit pattern, which is ones and zeros. That is fed as input into the SoC once it is fabricated. We have an expected output pattern that is supposed to come out if the device is working. And if the output pattern is mismatching, we will qualify it as, we will not qualify the device, we will drop it. Now using these additional test vectors allows us to check each functionality thoroughly, because similar to what we have done here, for all the standalone test cases, you can try to generate an equivalent software test case. Now, the strengths of our method is that it enables the reuse of the huge verification effort spent at module level. So module level is where most of the verification happens. But earlier, there was no way to convert it, the effort spent there, to test the fabricated device once it is available. So this enables the reuse of that effort. And the automated translation means that only minimal modifications are required to the sequences. The engineer need not spend a lot of time generating more test cases. Now, one weakness we could identify is that the current implementation that we have covers only stimulus coming from the processor. We focused on this because this was our major use case. The processor is the sole driver. It does not cover stimulus generated by blocks other than the processor. Now, to conclude, here we have presented a novel technique to utilize the verification space covered by unit level test cases to test the final fabricated device. Now, automation of this conversion reduces the burden on the engineer who would otherwise have to manually write the equivalent top level test case. The additional test case generated this way greatly enhance the confidence on the manufactured device, especially when using it for a critical application like aerospace. And in the future, this work can be enhanced by adding the automatic conversion of stimulus generated by multiple blocks of the SoC or interfaces. That's all from my side. Thank you. I'm open to questions. Thanks.
Okay, Mr. Rahul, thank you for your nice presentation. So I have one questions too. Can you please go back to your the model page, the main model framework? Okay, this one or this one,
This
the
one.
first and the sample one. Yeah, this is also okay. So
Yeah.
what type of device you use to check as a checker? Actually, checker. I
Okay. Sorry, I forgot to mention checkers. So checker is also actually a system Verilog test bench. So what it does is it checks the correctness of the interface, whether you're doing any illegal transactions on the interface, or whether the
Okay.
data you're writing to the interface is correct or not. Is it coming as expected? So this is also a system Verilog utility. It is a software that will
Okay,
check.
this is software. So
Yeah.
this implementation is hardware or software implementation, the full your applications like a soft memory and processor. You are using your implemented device, or you are just using a software that can act as a device.
Okay. So the first stage, what we do is we simulate the functionality of the device completely in software. So this figure actually represents how we simulate it. And the idea of our paper is to actually take it out into hardware. Once your fabricated device comes, how you can test the same thing in hardware. So first we simulate this, but in earlier scenarios, whatever we are able to simulate, we were not able to convert it into a wave that we can test in hardware. But now we are
Hmm.
trying to bridge that gap. So
Oh,
this
so
functional test vectors,
you just used to simulation, right?
yes,
Using different type of software. Later, you have a plan to implement these models in a device, right?
yes,
Okay. Okay. Thank you.
yeah, thank you.
Thank you.
Thank you so much, Rahul, for presentation. Now we can
Yeah.
call our next presenter, Sapna. Her paper presenting on effective online tools for teaching Java programming course on an online platform. Sapna, you may start your presentation. Sapna, are you there?
Hello, am I audible?
Yes.
Actually, ma'am, instead of Sapna Barfe, Varsha Lokre is going to present this particular
Okay.
paper.
No worry. Please start your presentation.
Yes, yes. I just share my screen. Whether my screen is visible, ma'am?
Yes.
Hello all. I am Varsha Lokre, working as a research scholar at Dr. Babasaheb Ambedkar Technological University, Loner, Raigad, India. I am going to present here on paper entitled Effective Online Tools for Teaching Java Programming Course on an Online Platform, along with my co-authors Sapna Barfe, Dr. S.R. Sutar and Dr. A.W. Kvekar sir. As if we consider a physical classroom teaching, in which it will be very easy for a teacher to identify whether students are learning or not. Okay, facial expressions or by asking questions. But due to COVID-19 pandemic situation, it is really very difficult for us as a teacher to check whether students are learning or not. You are teaching, but are they learning? But here in online platform, question may arise, you are teaching whether they are listening to you or not. So that is the what we can say major concern for this particular paper. Along with that, we have considered this Java programming language as a case study course. So to teach this Java programming course in online platform is really a challenging one. So for that, we have used various online tools which are freely available, like JDoodle tool is there. Along with that, CodeShare tool, and to ensure students' engagement, we have used Poll Everywhere. So this is the screenshot of a JDoodle tool. So if you consider advantage of this, like we don't have to install this, like students no need to install that particular software on their machine. Even if this tool is compatible with smartphones, like if any student don't have laptop with him or her, then they can work on their mobile phones also. It is that much user friendly. So here, in this particular portion, you can see where students can able to type their code, whatever problem statement given, they can type that code. So here input they can provide, and accordingly, this is the screenshot. Once they click on execute, likewise result will be there. One more thing about this JDoodle, like it is not going to help you for only Java programming language course. Along with that, it is going to support total 56 programming languages along with C, C++, or Python. Other than that, if we want to do collaborative learning in online mode, so definitely it is very difficult. In physical classroom, you can do that collaborative learning. You can assign some task in a group of 2 or 3 students, and work will happen over there. But in online platform, how you can do that? So here is the solution for that. Like suppose you have given any problem statement to solve within a group of 2 or 3 students. So in JDoodle, this particular facility is available in which suppose 2 students are there or 3 students are there. So one student can invite a friend and provide whatever link is available over here can share with another group member. So another group member can open that particular link on Together.js and can join the session. Okay, once that particular student or 2 or 3, whatever group members, if they join the session, they can collaboratively work on same code. That is the advantage of this particular JDoodle tool. Along with that, there is a facility that they can on their microphone and can communicate with each other. Even chat option is available, video chat is also available. So we have applied all these things while teaching this Java programming course in online mode. Also, a similar tool which we have tried, that is the code share. So actually, it has similar functionalities, we can say. So somewhat different GUI is there. Like this particular code, suppose one student want to share with another student, then whatever link is there, that student need to share that link with another student, and almost all functionalities are available. But as compared to JDoodle, here CodeShare don't have that much effective GUI. But all functionalities which are there in JDoodle also available in CodeShare. Also, we have taken feedback from students, and they said that they most of the 80% students appreciated the JDoodle tool. Along with that, to ensure students learning, or whether students are engaged or not, whether they are listening to you or not, so for that we have used polls everywhere online tool to ask questions in between, to ensure their engagement, to check whether they are learning or not. For that purpose, we have used this poll everywhere tool. And obviously, after that, we have compared their scores in examination. Like previously, when we have not used any online tool, just a normal teaching was there. And in test one, two tests we have conducted before and after. So before applying these tools, test one scores or marks out of 10, here you can observe between range of 0 to 2, 9 students was there, and after applying these online tools, it becomes 5. Similarly, in the range of 3 to 5, here you can observe like previously 62 students was there, and after applying these tools, that reduced somewhere over here. And major concern is here between 6 to 8. So from 42, 82 increase is there. So total 120 students we have considered for this particular analysis purpose. So here we have calculated their improvement in percentage. So obviously in the range of 6 to 8, and there is a good improvement. So finally, we can conclude that okay, teaching in online and specifically teaching programming languages in online is definitely a challenging task. So to make it easy, to make it user friendly, to engage students, we have use various types of tools like JDoodle, CodeShare, and Poll Everywhere. And with the help of that, students can code or compile, run their programs in virtual environment. In CodeShare, that editing facility, collaborative learning can happen with the help of JDoodle as well as CodeShare. Also, we can ensure student engagement with the help of Polls Everywhere tool. So overall, if we compare the scores in first unit test and second unit test, there is approximately 20% improvement in student performance. These are some references. Thank you. Thank you all.
So I have a questions. This
Yes, please.
paper is related to effective online tools for teaching Java programming course on a online platform. So
Yes,
I think your team have developed a tool like JDoodle, right?
yes, sir.
I
Yes,
think
sir.
so. This platform will support some programming language like a Java and C, C++, plus plus.
Yes, sir.
Okay. So is this tools is available in online right now?
Uh, shall I show that screen, sir?
Yeah. Just
Just a
for
minute.
because we have another
Okay, okay,
presenter, so it's a short time. Just
okay, okay. That that will be great for me, sir. Just a minute. I will once again share my screen. Let me check. Uh, whether screen is visible?
yeah, your screen is visible, but your tool is not visible yet.
Just a minute. Yes, sir. Now, is it visible? Screen is visible?
No, screen
This
is still
online
not
Java
visible.
compiler IDE.
No. Actually, it's okay.
No.
It's okay.
Once again,
So I can search it in Google because I've already seen the platform can support a lot of programming language, and student can attend in that. Student can use that
yes,
platform
sir.
for. Yeah, I already checked it. Okay,
Yes.
thank you for your presentation.
Thank you, sir. Thank you.
Okay. So next one.
Now we can call our next presenter, OL Mukhalsi. His paper presenting on exploring the means and the benefits of including blockchain smart contracts to a smart manufacturing environment water bottling plant case study. His dear presenter, you may start your presentation.
Thank you very much. Can you all see my screen?
Yes.
Okay. Okay, I'll prefer to. Okay, my name is Lucky, all the way from South Africa, Central University of Technology. I'll be discussing exploring the means and benefits of including blockchain smart contracts to a smart manufacturing environment. I'll be using a water bottling plant case study. So traditional manufacturing processes, they struggle from data fragmentation, data disintegration, and various regulatory policies, which in turn prohibit product data provenance. One may ask, but what is data provenance? Provenance is defined as the place of origin, the earliest known history of a product, which is tamper-proof, and its integrity across the supply chain can be verified. So in cases where there's lack of provenance, data integrity, and transparency and traceability, we've seen that during listeriosis outbreak in South Africa, where several people lost their lives due to the contaminated meat. In this case, it was a polony. So they couldn't recall the meat in time. In most cases, we say we have organic food, but we're not 100% sure of what we have on our table. And this is also evident with textile manufacturing, where they use what we call sweat labor. The biggest problem again is blood diamonds from Africa, where they cannot be traced back to conflict environments. So currently, some of the technologies used for ensuring data provenance in products are basically barcodes, radio frequency identification, which we normally call RFIDs. So barcode technology assists in keeping track of product information, but are stored on a local database. There are challenges with barcodes. As you can see, bad printing quality, smudged ink, damaged labels. And then if you look at the radio frequency identification, they are similar to barcodes, but they facilitate control and transparency in production process flow. They don't need a line of sight. They also store data on a local database. So disadvantages of a local database or a centralized system is because it is prone to be written, it can be corrupted and erased. And again, the end user without access to the local database cannot verify the product provenance. So blockchain is perceived as the solution in this case. So what is blockchain? Blockchain is a decentralized system which uses many computers around the world. Each computer is called a node. Each node can communicate with each other, enabling what we call as consensus. Each node stores a copy of all the data records available on the blockchain. Data is stored as blocks, which are chained together to make a public ledger. And then code is stored in a smart contract, which are immutable programs that run the blockchain. So blockchain is a write-only distributed database, meaning its transactions are trackable, irreversible, and can only be added, not edited or removed. So blockchain principles offers the end user increased security, transparency, and traceability. So its principles can be applied into a smart manufacturing environment or a supply chain, from the raw material to a product which ends up with the end user. So in this case, we looked at a water bottling plant and introduced blockchain principles. The water bottling plant consists of 3 smart manufacturing units. The smart manufacturing units are optimized to fill, cap, and package the water bottles in an automated process flow. The first section of the experiment is basically data collection using RFID tags, and then development of a smart manufacturing protocol, and the development of a decentralized application which is used to retrieve data from the blockchain. Let's look at data collection. So data collection, it can be, we can use QR codes, barcodes, or which are etched on the bottle. But however, in this case, a RFID tag is preferred as it reduces the need for a human to manually log the data. So the data that is logged is not limited to the manufacturer details, source of water, the composition of the bottled water, the date of filling, and the date of packaging. Data from the RFIDs will then be logged into a smart contract, which is then deployed to the blockchain. How do I go about incorporating data into the blockchain? The data per order from the end user, or it can be a batch or a pallet, is given a unique product number, which is stored in the RFID, and then a smart manufacturing protocol based on the global standards, which are methods for universal and global standards. And then all that is implemented into global standards incorporated into a smart contract, which will then facilitate the increase in transparency in a smart manufacturing environment. Data from the RFID will be logged into a smart contract and deployed into the blockchain. So the end user at the end receives a decentralized application, which can be used to verify provenance and composition of the bottled water. The decentralized app is a web-based application that communicates with the blockchain, and in this case is developed using the Ethereum blockchain. So in conclusion, the end user will then use a developed blockchain data provenance tracking decentralized application that scans the water bottle tag, retrieves the contents and manufacturing flow data from the blockchain, operated in a decentralized manner to ensure secure, transparent, and trustworthy product provenance. In the future, the plan is to also integrate payments into the smart contracts and also see the need of including autonomous delivery, even using drones. Thank you very much. If there are any questions, I can take them now. Hello?
Okay, thank you for your presentations. Okay, I have no question right now, so thank you.
Thank you very much.
Thank you so much, presenter, for a nice presentation. Now moving ahead, I would like to invite our next presenter, Mihir Monde. Is a paper presenting on energy efficient cluster formation for a wireless sensor network using fuzzy logic.
Am I audible?
Yes, please.
Yes,
Mihir, you may start your presentation.
Yeah, I'm sharing this. Is my screen visible?
Yes.
Okay, so hello everyone. I am Mihir and I'm gonna present some energy efficient clustering in wireless sensor networks. Like we have proposed algorithm. I'd like to explain it. As we all know, wireless sensor networks, they are basically the sensor nodes in a network. So while we know in the world of IoT, we used a lot of wireless cameras or wireless many applications. They are called as nodes in this language. And the main problem is when we transfer data from that particular node to a base station, it takes a lot of energy, and like if it isn't wireless, and if the node doesn't has a proper source, energy source, then it will get exhausted soon. So basically we are forming clusters. For that we are using a fuzzy based approach, which is an artificial intelligence approach. As I mentioned, the motivation was the motivation to do this was to consume less battery and less energy. So the main goal is to improve the lifetime of the network and increase the time it stays alive, the nodes in the circuit to stay alive. For this we did we did some research and we referred some papers. There were many approaches used, such as particle swarm optimization, and genetic approach was also used in many papers, in which they were calculating fitness function, and on the basis of fitness function they were allocating cluster heads. So basically a cluster head is someone who will collect data from all the nodes in the cluster and he'll send it to the base station. So we referred many papers, and we came to a conclusion of using a fuzzy base approach. I'll also like to explain this fireflies algorithm. So basically in this algorithm, what they used to do is they used to what a firefly does is they'll search for food, and then later they'll leave their some kind of acid on the way. So basically more the acid, the rest of fireflies will follow the same path to find the food. So this kind of approach was also used, but ours is a fuzzy logic approach. So basically, in the model uh, we we propose, in which there are two parts: base station and sensor nodes. So base station will send the a request message to all the sensor nodes, and then after receiving, the sensor nodes will send the self information to the base station. Self information as in how much residual energy they have, where is their exact location, and all. After that, we have some fuzzy inputs, in which we will take the inputs, we will run a fuzzy logic, and we will see what are the cluster heads. Then we will send the information of cluster heads to again to all the nodes, such like the cluster heads will know that they are the cluster heads in the circuit. So they will if they are cluster heads, then they'll broadcast the message in nearby clusters that they are the cluster head. If they are not the cluster head, then they'll wait for the message from cluster head to receive, and then after being the cluster head, the nodes will know that they have to send their information, the collected information, to this particular node in the circuit. So they'll do that, and if the cluster size is full, then it will broadcast that message to the base station, and then we will change it for the next round. So yeah, that's it. And for calculating fuzzy logic, we are using these parameters: energy level. And energy level is basically how much energy the node has after it started its after it started the what we can say, the rounds, like before and uh, after transmission, how much energy level is there. node centrality is in how much center, like in a cluster, how much center it is, how much nodes it has between it or nearby it. And the node degree is also the chances of a node being a cluster. So it's also similar, like how many nodes it has in near. So the cluster head will send the ID with chance to its neighbor, like I discussed earlier, and the chance will be calculated on this basis. After calculating the chance, we will select the maximum. We will select the maximum nodes who have chance, and then we will name them as CH, and then we'll calculate the distance from the node to the base stations. For doing this, we have used MATLAB simulator to simulate this code. And the applications of this are like we can use it in military surveillance, forest fire detection, flood water direction. For military, if there is a thief or there is an unwanted person in the area, we can find it using a sensor nodes. For there are fire sensors, fire detecting sensors by which we can know if there is a fire or not. Like it will send the sensor will send the data to the base station. And flood water detection also, we have sensors. We use it in this. We use wireless sensor networks in this. So yeah, that's it.
Okay.
Do you have any
Here,
questions?
thank you for your presentation. Right now, I have no questions, so that's all.
Thank you, Mihi. Thank you for your presentation. So we had completed our all presentations. Now, I would like to thank you all participant and presenter to the excellent presentation in this session. And again, I sincerely thank you all participants for being a part of this international conference. And I hope this session was informative enough. All the presenter would be getting digital certificates through email within 2 working days, and all paper has already forwarded to the Springer, and publication will be live within 5 to 6 months. Please cooperate with the team of WS4. And I also thank our session chair for chairing this session. Thank you so much, sir, for your valuable time. And I kindly request to my team to display the certificate. So it is a token of appreciation on the behalf of Team WS4 and the Global Knowledge Research Foundation.
Thank you.
Thank you so much, sir, for your valuable presence.
Thank you to all.
Now I would like to kindly request to everyone, please turn on their cameras for a quick snapshot for making this conference more memorable, and a display on the conference website. Please turn on their cameras. Thank you so much, everyone. Thank you. Stay safe and take care, everyone.
Thank you to all.
Thank you all.
Thank you, everyone.